everyone, Jain to all. In this video lecture, I am going to discuss about the basic concept of theory of automata. Basically, this subject is known as theory of computation, but in this Akgec University, this subject is running with the name of theory of automata and formal language. This is the name of the subject Tafl, theory of automata and formal language. In this starting of the video, we want to discuss what is meant by theory of automata and how we have to implement this in the technical computers. The definition of theory of automata and formal language, this defines what is meant by theory of automata and formal language. This is combination of theory, automata, formal and language. This is the four words which combine to form theory of automata and formal language. First, we define what is meant by theory of formal language. Theory of formal language, that is Tafl. It is also known as theory of computation, which is discussed in the previously. This subject is basically named with theory of computation, and Akgec University running with the name of theory of automata and formal language. Is a theoretical branch of computer science. That's the main points in the theory of computation. Is a theoretical branch of computer science where we have to discuss about how the string is computed or how we have to check the error inside a given data. Tafl mainly deals with logic of computation with respect to simple machine referred to as automata. Automata means a distinct model of digital computer. If we hide all complexity of computer and we show only an essential part, that is known as abstract, and that is called automata. Means automata is the discrete model of digital computer. Tafl is the abstract model machine or abstract model of digital computer, which is explained in the previous points. This is the abstract model of a digital computer, which show how we have to process the string, how we have to construct the different types of tables, or how we have to process the data, or how we have to check the logical or error inside the given data code. This is the Tafl is a mathematical model. This is the mathematical concept. How we have to call or why we have to call it is a mathematical model, because it is used to process the string which is in the form of 0 and 1, like this 0, 0, 1, 1, yeah, A, B, A, like this. Such type of string is processed by this machine, so that we have called it as a mathematical model. The next one is automata, originated from the word automaton, which closely related to automation. This is a form of machine which automatically execute the given code or given string and generate the output. This is the basic concept about the theory of computation and formal language. The next topic is application of Tafl. Where we have to use theory of automata and formal language, and what is the need of this subject or what is the need of this type of machine, so that we have to design this machine for a processing of string. The first point is Tafl are used in artificial intelligence, embedded system, but most widely used application in the compiler construction. This is the main point. Compiler is a program which convert one form of language into another form, and such type of designing of compiler, we have to use automata to check the error of a given string, that string is correct format or not, the syntax of the given string is correct or not. For such type of checking, we have to use automata. They check whether the language written is correct or not. That means by using the automata, we have to check the given syntax is grammatically correct or not, or the string is correctly written or not, so that we have to process the next step. The next point is automata enables scientists to understand how machine compute the fundamental function and solve problem. It is also help to scientists to understand about the functionality of the given machine, how the machine is working, how the string is processed, or how the output is generated. The main motivation behind developing automata theory was to develop a method to describe and analyze the dynamic behavior of discrete system. A system which is discrete, that means there is no relation between previous model and next model. Such type of system, we have to use automata to design such type of discrete model. Now, this is the next topic, that is naming in the basically in the topic the introduction of Tafl, and this is the part is the fundamentals of theory of automata and formalling. Before starting this subject, we have to discuss the symbols which are used in the automata, the alphabets which are also used in the automata, the string, length, concatenation, reverse. This is the operations which are used on a string. Firstly, we want to discuss what is mean by a symbol. This is the basic terms which is used to design any type of machine, that is the form of PDA, or that in the form of Turing machine, or that in the form of finite automata. We have used number of symbols, number of alphabets to represent the machine states and symbols. The first point is symbol. This is nothing new. This is the any alphabets, character, or letter or picture which is used to represent the information. I have number of information, and if you want to represent such information in the form of symbol, so that we have to use such type of symbol. Smallest building block which can be alphabets, it may be alphabet, it may be letter, or it may be picture. It can be anything like this, A, B, C, 1, 2, etc. Yeah, it may be picture to which is used to represent the symbols. The next one is alphabet. Alphabet means this is the set of sigma. This is also called input alphabet. And alphabet are the set of symbols which are always finite. This is the words is already used in the next point. The symbol must be, our input symbol must be infinite, because we have to process finite data. We don't try to process the infinite data, so that we have to use only finite terms in case of processing, or in case of input symbol, or in case of designing of machine. This is an example where we have to take sigma is equal to 0, 1, or sigma equal to A, B. That means this all symbols belongs from these points. It may be in 0, 1 form, or it may be AB form, or it may be in pictorial form, but the symbol must be defined from the given set sigma. If 0, 1 is the set of sigma and AB is also the set of sigma, so we have to define a string which only from 0 and 1 are, which only from A and B. We don't use other than 0 and 1 are other than A and B. Now, the next one is fundamental of Tafl continues, in which we have to discuss about string. The third point is string. String is a finite sequence of symbol. As we discussed in previous slide, if sigma equal to 0, 1, that means this is your input symbols. We concatenate 0 and 1 and construct a sequence like this, 0, 0, 1, 1. This is called string. So a string is a finite sequence of symbol from some alphabet. A string is generally denoted as W. W is a name of string, which may be W1, which may be W2, or which may be W3. But here we have to derive a single terms string, so that we have to write here W. That means string is denoted by a symbol W. Here we have to take an example, sigma equal to A, B. Now we want to construct a string by using this symbol, we have to construct W1 equal to A. It may be possible. We have to take in one symbol from input alphabet, or we have to take in only A or only B. This is also a string, W2. Or this is also a string AB, AB. That means we have to obtain sequence of AB from input alphabet A and B, and concatenating this, we have to construct infinite string. But here we have to only discuss about finite term, so that we don't take a endless string. We have always take a string with fixed length. We not consider a string that length is infinite. So that here the W4, double A, double B, double A. This is a string which have derived from input A and B. If we talk about the length of W1, here the length of W1 is 1, here the length of B is 1, here the length of W3 is 4, here the length of W4 is 6. That means the length is the number of symbol in the given string. Here we have to define length. Look at the definition. Length is the number of symbols in the given string. The length of the string W is denoted by mod symbol. If we want to find length of W1, we have to write mod of W1 equal to 1. We want to find the length of W2, mod of W2 is 1. If we want to find mod of W3, the mod of W3 is 4, like this. That means number of symbol in the given string is called length of string, or length of that string. Here we have written some example. We have taken W1 is A, so the mod of W1 is 1. Here we have taken W2 is as B, so mod of W2 is 1. W2 is 1. Here W3 is AB, AB, the mod of W3 is 4. And here the W4 is double A, double B, double A, so that the mod of W4 is 6. This is the basic terms which is used for calculating the length of the given string. Now, the next point in the sequence of fundamental of theory of automata is concatenation. This is the most important point. What is mean by concatenation? In previous point, we have discussed about the string. String means sequence of symbols, which symbols belongs to input alphabet A and B is called string. If we combine one or more string, then that is called concatenation. Here we have to taken two string W and V. We want to find W dot V. This is called concatenation, or V followed by W. This is also called concatenation. In this operation, we have to write the symbol of W first, then we have to write the symbol of V after W. Here we have to write symbol of V first, then we have to write symbol of W. We have to preserve the sequence of W and V. If W is before V, so we have to write the symbol of W before V. If the V is before W, then we have to write the symbol of V before W. This is the definition. The concatenation of true string W and V is the string obtained by appending the symbol of V to the right end of W. This is the main funda. We want to find W dot V. So we have to append the symbol of V to the right of W. This is the string of W and this is the string of V. We want to find V dot W, and this is A1, A2, A3, A4, A5 up to AN. This is the string of W. After that, we have to write the string of V. Now, the next point is how to reverse the given string, just like in any types of reverse, we have to also reverse the given string in case of given sequence. Here, if the given string of W is this one, A1, A2, A3, dot, 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 AN, we want to find the reverse of W, W power R. So, we have to write AN, then AN minus 1, then AN minus 2, like this, last A3, A2, A1. This is the sequence which obtained after reversing the string W. That means we have to given string W and we want to find the reverse of string W, W power R. Now, the summary about this fundamentals is, the summary of this fundamentals is, the first point is empty string is the string with zero occurrence or symbol represented as sigma. We have to also consider an empty string or a sigma which denotes the empty string that is represented by sigma. It may be considered like this, or it may be considered like sigma. The next point is, for alphabet A comma B with length n, number of string can be generated to power n. If we have A and B, two symbols, and we want to find the number of string that can be generated for the given input A comma B, that is 2 power n. This is the number of string that can be generated from A and B. N is the with length n. With length n. If we have three symbols A, B, C, then we can generate 3 power n string of length n. N is decide the length of the string, and here this decide the number of symbol. Here 2 because there are two symbol and n is the number, n is the size of string. Now the next point is sigma plus. This is called positive closure. This represent a set of all string except null or null string. This is also called, sigma is called set of input symbols. But sigma plus and sigma star, it is two different things. Sigma plus is called positive closure and sigma star is called clean closure. In case of clean closure, we have include null. In case of clean closure, we have to include null, but in case of positive closure, we remove null. That means, in case of sigma plus, we don't include the null. That means, set of all string concatenating one or more symbol is called sigma plus. But in case of sigma star, the set of all string concatenating 0 or more symbol, it includes 0, but it does not include 0. Here we have to write that represent a set of all string except null or sigma string. Here it is clean closure that represent the occurrence of certain alphabets for given language, alphabets from 0 to infinite number of times, in which null string is also included. This is the basic fundamental which differentiate between sigma plus and sigma star. This is the basic difference. Sigma plus does not contain null, where the sigma star is contain null. Now, this is the basic example for sigma plus and sigma star. We have taken a sigma where the input symbol is A. We construct sigma plus that we have discussed in definition. Sigma plus is the set of string including one or more symbols, sequence of one or more symbols. Here sequence of one symbol, that is A. Here sequence of double A. Here sequence of triple A, 4 times A, 5, like this. This sequence, set of sequence is called sigma plus. Look at this sequence, null is not included. But if we include null, then it is called sigma star. Then this is the main difference between sigma plus and sigma star. Now, on the behalf of these two topics, we going to define language. This is the most important part of this theory of automata and formal language. A language is the set of string chosen from sigma star. If we want to take a sequence from sigma star, that is called language. Or we can say a language is a subset of sigma star. From the sigma star, we have to take a sequence of string and we construct a next set. That set is called sigma star. Here, a language that can be formed over sigma can be finite or infinite. This is the main part of the given input alphabet or set of string. In case of input alphabet, we tell the set of input alphabet must be finite. Here also, the set of string also must be finite. We can't use infinite set. We always use a finite set. This is the relation between sigma plus and sigma star. As we discussed, sigma plus means without null, sigma star means including null, and sigma plus means excluding null. So that we have to write a formula, sigma plus equal to sigma star minus null. If we remove null from sigma star, that should be equal to the sigma plus. This is the main relationship between sigma plus and sigma star. Now, the next topic, which is the part of theory of automata and formal language. We discussed about what we mean by language. Language means set of string which is derived from sigma star. Here, we discuss some basic concepts about the grammar. This is the also main part of the theory of automata. Theory of automata mainly contain three parts: automata, grammar, and language. We discuss about automata, what is mean by automata. That is the discrete model of digital computer is called automata. Then we have discussed about what is mean by language. Language is the, if we talk about the general life, the language is the mean of communication. But here we want to discuss about what is mean by grammar. Grammar means how we have to communicate with a particular sentence. What is the format of the given sentence? In this, we have to use set of rules to govern communication. For using the grammar, we check the sentence is correct or not. This is the set of rules which is used in automata. We have the given sentence, that sentence is grammatically correct or not. By using this, we have to check, or we have to generate the language for the given grammar. This grammar contains two topics. We have to first convert grammar to language and then language to grammar. This is a technical definition of grammar. A grammar G is defined as four tuple, G equal to V, T, S and P, where V is the finite set of object called variable, T is the finite set of object called terminal, S is a special symbol called start symbol, and P is the set of production. These four tuples define any type of grammar. V is the set of non-terminal, and non-terminal is always a capital letters. Where T is the set of terminals, and terminals is always in a small letter. Where S is a special symbol that is called start symbol, means if we have given number of production and which production we have to pick first is decided by a start symbol. And last one is the P, which called set of production, which decide how many types of production we have to use or where we have to start the given production to process the given data. This four tuple grammar is converted into language by given set of rule, and after converting the language, if we have to given language, then we have to convert also back to the grammar. There are two types of question on this topic: grammar to language and language to grammar. This is the simple rules which x derives y. What is mean by x derives y? Yeah, what does mean by w implies z? This is the formal notation ki how the string is replaced by the other string by using the given set of rule. Here a grammar G is given like this: G equal to S A comma B, that is the terminal, that is also called input symbol, S is the start symbol, and P the set of production. By using this set of rule, we have to find the language which is generated by above grammar, and the language generated by the above grammar is derived like this. First, we have no knowledge about the start symbol, or we have to know option, then we have to choose a S derives null. We have to derive a string that length is null, or we have to pick up a first production S derives ASB, then the smallest string derived by this production is AB, or we replace ASB again ASB, then derive this string. Like this, we have to derive a sequence of the form A power n, B power n, where n is greater or equal 0, because this is the first production which derives null, and if we have to put n equal to 0, that decide to derive this string. This is the first question which is used to generate the language for the given grammar. Thank you. If any doubt in this topic, you can message in comment box. Thanks.